Phonograph record processing represents a significant part of the Stereolab software suite, as shown by the number of menu items and a settings dialog entirely devoted to phonoprocessing. And that's because Stereolab has an ambitious aim, that it provides the very best signal processing and equalisation for any phonograph or gramophone record, from the earliest acoustic recordings to modern LPs. The signal from a gramophone record is too small to apply to the line input of most amplifiers or sound cards when making needle drops. In addition, the signal from the pickup must be equalised, otherwise the sound is shrill and artificial. Normally a phonopreamplifier is used to boost and equalise this signal for recording. Phaedrus and Spatial Audio believe that after 60 years, hardware phonopreamplifiers have just about reached the end of the developmental road, and that equalisation is nowadays better performed in software for the following reasons. The human hearing system has a dynamic range of about 120 dB, and the very best analogue circuits can just about match that range. But by doing the equalisation and processing in software, we can use double precision floating point math, and that has a precision of 53 bits or 320 dB. Even the very best analog components can only be manufactured with a certain degree of accuracy, and that's really better than 1%. And physical components are also subject to aging, such that they go off value, whereas digital processing ensures perfect channel balance and frequency response forever. LPs don't exist in a perfect world, so when warp and rumble are inevitably present, they need to be eliminated. And the rumble filter in Stereolab is a phase linear non-causal design, which means there's no phase distortion introduced. Conventional wisdom has it that by the mid-50s, all European and American labels had adopted RIAA, but in fact it's a much more complicated situation than that, and many believe that it wasn't standardised until well into the late 60s. In addition, for any vinyl enthusiast who's interested in older LPs or own Shellac records, we need a whole range of equalisations, and that's easy to do in software and very hard to do in hardware. Having the audio represented as data, we can use modern signal processing techniques to correct for some of the inevitable imperfections in the analog medium, including reducing various forms of tracking and tracing distortion, wavelength loss, and for imperfections in the phono cartridge which affect frequency response and channel balance. So let's start at the beginning with pre-electric or acoustic records. Acoustic recordings are those records made before about 1926, and these recordings it was simply the energy of the sound of the musicians themselves captured via an acoustic horn, which drove the mechanical stylus and engraved the groove in the wax master. These early discs require special treatment in played with modern record pickups, and Stereolab provides this. The coming of radio in the 1920s was pretty much the nemesis of record companies, because following the introduction of radio, record sales crashed from over 100 million records sold in 1921 to less than 6 million 10 years later. Not only was music free on the radio, but the sound quality was far superior to the mechanical recording of the gramophone. It was clear that record companies needed to up their game if they were to survive. And that improvement came from Bell Laboratories, which was the research division of the US telephone company AT&T. Bell developed an electric system of recording, which Western Electric, the manufacturing arm of AT&T, called the Westrex electric recording system in 1926. An essential part of the Bell system was roll-off in the intensity with which bass frequencies were fed to the electrical recording cutter. This filtering was universally known as turnover. When record collectors talk of turnover frequency, it's to identify the frequency at which this filtering is applied. And we have a range of different turnover frequencies appropriate to all gramophone records of that period. As time went on, in addition to this bass filtering idea, the treble frequencies were boosted too during recording, and this meant that the treble could be toned down on replay, and that helped reduce surface noise. This strengthening of the treble signal is called preemphasis, and it's also an innovation stolen from radio.
Once I built a tower.
Now these two ideas of turnover and preemphasis were so widely regarded as a good idea that more and more of each was added by various companies throughout the 1940s. The choice of frequencies at which to cut and which to boost is known as the recording characteristic, and there were many. And we believe, an encyclopedic range of different recording characteristics, different turnovers, different preemphasis within the software. Now eventually turnover and preemphasis are such a good idea that they almost met in the middle, which is more or less where we are today, what is known as the RIAA characteristic, the one with which all modern records are recorded. And of course we support that. So let's have a look at the menus for equalisation. So you're looking at RIAA, that's modern equalisation. Now looking at historic, you have a whole range of historic Decca, Teldec, NAB, Columbia. And just notice that if you hover on any of the equalisations, you have a context-sensitive help which pops out. And that's a quick way to choose which is the appropriate equalisation. Although we do also, with the software, publish our own equalisation guide to help you to select the appropriate equalisation given the date and provenance of the disc. Much of the information here is based on our own unique research too, some of which has uncovered some interesting anomalies with some of the received wisdom concerning historical equalisation. In each case, we've always gone back to primary references because there's so much muddle, especially online. Now, a little appreciated fact about phono equalisation, even amongst collectors, is that you need to equalise both the amplitude and the phase. Now, reciprocity is a byword of recording characteristic and replay equalisation. And essentially, if that characteristic is what's recorded, so let's say here there's cut bass and boosted treble, then what you need on replay is a complementary characteristic, and that's well understood. But in fact, you need reciprocity in both in frequency and phase. And importantly, the correction curves in Stereolab are not derived from FFT curve filtering. Such a technique results in generation of non-causal linear phase filters, which do not correctly compensate for the phase distortion introduced in the preempsis filter. Unfortunately, this is the technique employed in most of the software solutions commercially available. Not only does this technique result in frequency response anomalies, we've measured around 1 dB errors, but much more seriously it destroys the linear phase response of the preempsis-deemphasis chain. So this is what happens when a sin x over x pulse has been encoded by a standard RIAA stage and then decoded in a perfect analog filter. So that's the sin x over x test signal. That's what it looks like once it's been encoded in the RIAA encoder. And if it's decoded with a proper analog circuit, it comes out looking the way that it went in. So not only have the frequency components been recovered, but their phase is recovered too. And that's exactly what happens with Stereolab. If you instead use the FFT curve fitting filters, once again the sin x over x goes in, encoded into RIAA, but that's what comes out. So the frequency is compensated, but the phase is not corrected. Only Stereolab has the software implementation of real analog filter structures. The transfer function of the filters is the conjugate of the Hallberg filters in the cutting lathe. And we checked that too. Once again, back to our point about primary references, we researched the encoding filters in real record lathes to check that our filters were true conjugates. Okay, so now I hope you understood it's a good idea to equalise in software. But how do I obtain an unequalised disc recording? Now, just as the signal from a gramophone pickup is too small to apply to the line input of most amplifiers, so it's also too weak to apply directly to computer sound card or audio interfaces. So although we don't need an RIAA equalising preamplifier, we do still need a dedicated phono preamplifier to bring the small signal from the cartridge up to a healthy level for the input of the computer sound card. We need a preamplifier which provides gain and impedance conversion without applying the equalisation. Now, commercial phone stage is a good place to start here, and you can do a number of things DIY. Normally the designer of a of a phono stage, has looked carefully at the noise issues and all the rest of it. So it's very easy to in fact modify an RAAA stage to take out its equalisation. And models are available at all price points, obviously. And we have quite a bit of information in the help pages to explain how one would do that modification. Now the alternative is Phaedrus Audio's Groove Sleuth preamplifiers, which were developed in conjunction with Spatial Audio's Stereolab and guarantee extremely low noise, exemplary headroom, excellent linearity and an accurate and extended frequency response. The Groove Sleuth Mark II supports all moving magnet cartridges with an option to install very high quality mu metal screen transformers to support moving coil types. The preamplifier also supports the Phaedrus Audio Flux active moving magnet cartridge, another Phaedrus Audio innovation and our recommended configuration. A further advantage of the Groove Sleuth Mark II preamplifier over and above the DIY solution is the inclusion of iLoop, a wide bandwidth, low noise and distortion buffered loop through. So this is especially convenient for enthusiasts who already have an excellent LP replay system but who want to introduce computer audio into their system. This is because the Groove Sleuth Mark II integrates transparently into a pre-existing setup and provides the new functionality without upsetting what's there already. So we can see that the signal there from the record deck goes to the computer via the Groove Sleuth, and then via the iLoop goes back to the phono preamplifier. Now for those without an existing phono preamp, the Groove Sleuth may be purchased with a line output option. So there we are, that goes to the computer and the signal then equalised goes back to the main amplifier. Because Spatial Audio's Stereolab software has its greatest application in equalising the many recording characteristics of historical recordings, it was felt helpful to incorporate limited variable equalisation in the hardware preamplifier. Let's have a quick look at the architecture of the Groove Sleuth. So there we have the main signal path from the cartridge through either a transformer or not, depending on whether it's moving magnet or moving coil, through a flat preamplifier and then to the output. And then the iLoop may either be a looping option or it could be the equalised one. And there we are, there are the three options, so RIAA early and pre-RIAA. Those are the three settings. Now a further innovation of the Groove Sleuth Mark II is a very low noise battery supply. This means the preamplifier can be powered from a conventional international style power supply, little plug top power supply, but be switched to the battery supply during the needle drops to ensure very best possible noise and aliasing performance. There's a switch on the front panel, you can see on the right there between charge and play, which allows the batteries to be selected, and the green LED indicates that the battery health and charge. Now, Stereolab isn't just about equalisation. It also includes an audiophile click and pop removal process of our own design, which is optimised for fans of the vinyl disc, whose LPs are in good condition and for the most part need little or no correction. Importantly, the Stereolab algorithm doesn't interpolate or predict the audio. Instead, a robust click detection algorithm is coupled to an adaptive attenuator, which lowers the intensity of clicks rather than attempting to remove them altogether. In this way, audio is never lost and it's never synthesized. So as an example, here we have a record made in the 1950s on the Decca's then state-of-the-art FFRR system, which was what they used prior to RAAA equalisation. If RAAA is used to reproduce this disc, the bass is overboosted and the treble is muted. The short example I'm going to play below are in two parts. The first half is a recording of an all-analog needle drop, recorded via a very high-quality RAAA preamp, and the second section is the same musical segment recorded with Groove Sleuth preamplifier and processed by the Stereolab. Note the overboosted bass in the RAAA version, which exaggerates the record rumble, and note the woodwinds in bar 6. There's much better focus to the sound through Stereolab, and also listen to details such as the cough during the horn call in bar 4. It's very hard to hear in the analog needle drop. Stereolab also includes unique processing for 78s, or more correctly, Shellac era records. For example, Gradient is a unique noise reduction process for Shellac era needle drops, included for the first time in Stereolab. The development of Gradient followed much experimental work on Fourier-based noise removal, all of which proved pretty disappointing. Although transform-based noise reduction produces noticeable and worthwhile improvement in the noise, it also introduces unpleasant audio artifacts which include birdies and a hollow ringing quality to the program. The Gradient solution was empirically devised and was tested in extensive listening tests. It uses a unique algorithm which radically reduces surface noise without removing high-frequency information. The Gradient also acts to reduce tracing distortion and correlated noise due to groove damage. Stereolab corrects for the following distortion mechanisms: pinch effect, lateral tracking distortion, provided this distortion has been reduced to the minimal level by the appropriate geometry of cartridge, and vertical tracing distortion. Now the algorithm must be applied to needle drops made prior to RAAA correction, because by this means the correction is applied in a frequency dependent way. From a sound quality point of view, the result of the distortion reduction process is substantially to reduce the garbled quality that especially plagues loud inner tracks on LP, and it reduces the splash and raggedness in the stereo image because the tracing distortion is taking place in the vertical signal. Now, nothing in the world is perfect, but phono cartridges remain one of the most fragile links in an analog reproduction chain, and unsurprisingly so, because the phono cartridge designer's task, a blend of high-tech and watchmaking, is staggeringly difficult. Even in the best cartridges, the channel balance is rarely better than about 1 decibel, and the cartridge balance is designed to rectify these differences. The algorithm in Stereolab intelligently discovers any imbalance from the program signal and corrects from any cartridge imbalance which exists. Wavelength loss is due to the physical fact that the sharp chisel is used to record the disc, and a rounded stylus is used to reproduce it. And the sharp chisel is capable of cutting sharper corners than the stylus can read, and this results in high frequency loss when the recorded wavelengths approach the dimension of the stylus. And the stylus acts in effect as a physical low-pass filter, as you can see in the picture. And the wavelength on a record is a function of both recorded frequency and groove radius, so scanning loss becomes more of a problem towards the centre of a record. Now, so guys at CBS back in the 60s made a very full mathematical model of wavelength loss, and because it's all maths and we have the audio as data, it's simple for us to correct for that. So the various signal processings are accessed via the Phonograph page of the Preferences dialog. So let's have a quick look at that. So you can see here channel balance, flux, response correction, that's we've just talked about that. That's the distortion cancellation, and it depends on stylus radius which you program in. It shows the various different noise reductions for LPs and 78. That shows the gradient middle, hum removal. So to sum up, Phaedrus audio hardware solutions combined with spatial audio Stereolab software offer needle drops with greatly increased resolution signal handling, unprecedented filter accuracy, stability and perfect left-right channel matching, better warp and rumble handling with phased linear filtering, and flexibility of equalisation to cope with records not equalised with the RIAA curve. Furthermore, DSP techniques designed to reduce artifact surface noise and distortion.